to the Poisson distribution. In the binomial distribution, we were dealing with the number of successes in n trials. In the Poisson distribution, we are dealing with the number of occurrences in a, let's say, in a continuous universe. What is this continuous universe? It's like, for example, time, distance, area, something like that. So, and the number of occurrences is, for example, the number of clients per hour, the number of gas stations every 10 miles, the number of defects every square inch, and so on. So this is what the Poisson distribution is dealing with. So the probability of x is given by the formula lambda to the power of x, e to the minus lambda divided by x factorial. Okay. What is e? E is nothing but a constant. Your calculator has e. It is 2.71828182.8. So it's just a constant, like pi. So don't worry about that. Okay, what is lambda? Lambda is the only parameter for the Poisson distribution, and it's the mean rate. Like in the binomial, we have two parameters: the number of trials and the p, that is the probability of success in each one of the trail. In the Poisson distribution, we just have lambda. An important consideration for the Poisson distribution is that the mu is equal to lambda and the variance is equal to lambda. So pretty easy, pretty simple. That's it. That's it. I mean, really, that is basically what is the Poisson distribution about. Let's do an example. Suppose that I have a restaurant, okay? And I have a mean rate of 10 customers per hour in my restaurant. So this 10 customers per hour is my rate. So that is my lambda. 20 customers per hour is my lambda. 20 customers per hour. So my lambda is equal to 20. I'd like to know what is the probability that in the next hour, whatever hour it is, I will receive exactly 10 customers. Go to the formula. It's lambda to the power of x, 20 to the power of 10, e to the power of minus lambda divided by x factorial, 10 factorial. Okay? So if we do that, let's see, 20, okay, 20 to the power of 10, 10 is equal, okay, 10 factorial, okay, that is equal to 0.0058. Okay, is 5.8 times the power of minus 1. Okay, that's how you can do it. And as in the binomial distribution, we have tables. The tables are in your book. And the table starts on page 852. And over here on the top or in the bold numbers, you have the lambdas. So I have to look for lambda equal to 20, and that is on page 857. It starts in 856 over here. This is my 20, okay? And go to the 20 and then go to 10. That is the probability of 10 customers, and I'm going to see 0.0058. It's exactly what we have here. So we can have what? The formula, we can have a table, or we can use the TI-84 as well. Okay, for the TI-84, you need to go to distributions. So second, distributions, okay? Go down until you find Poisson PDF. Poisson PDF, be very careful, PDF. Hit enter, and what the calculator is going to ask you is the lambda, that is 20, comma, and then the number that you want to use, 10, equal, and is 0.0058. It's exactly the same result. Okay? So either you use the formula, or you use the table, or you use the TI-84, it should give you exactly the same result. Okay. What if I want to know what is the probability that x is less or equal than 10? Again, exactly the same thing for the binomial distribution. Instead of using the PDF for one particular value on the distribution, we're going to use the CDF, that is the cumulative distribution function. And if I want to do that, and of course, this is equal to probability of 0 plus probability of 1 plus probability of 10, and the 10 is included because less or equal. So in your TI-84, again, you have to go to distribution, second, bars. We'll go down when it says Poisson CDF, hit enter, okay? And again, it has to give you the lambda, comma, and less or equal than what? Than 10. Hit enter, and the probability is equal to 0.0108. And that is the same probability that you would get doing manually 0, 1, 2, 3, 4, up to 10 and add all those numbers. Or if you go 10, you have to add this number plus this one plus this one plus this one up until here. Okay, so the probabilities, and again, when you add all the probabilities, possible probabilities, they have to be equal to 1. So again, if you are dealing with what is the probability that x is greater than 5, it has to be 1 minus the probability is x less or equal than what? Than 5, because the 5 is not included in here, so it has to be included in here. What is the probability that x is greater or equal than 5? Is equal to 1 minus the probability of x is less or equal than what? I want to include the 5 in the complement, so less or equal than 4, and so on. So it's pretty easy. It's really pretty easy. This distribution, when we have the mean rate of whatever, it can be, for example, the number of gas stations in a 10-mile highway. Okay. Poisson has this particular issue. For example, I have a lambda of, let's say, 0.5 gas stations every 10 miles. Okay? This is my lambda. This is the rate, the mean rate of number of gas stations every 10 miles. I want to know what is the probability that I found 2 gas stations between Americas and Albany. Let's assume that between Americus and Albany there are 30 miles. Okay, so I need to adjust my lambda into my distance. So in this case, I need to find or adjust my lambda is equal to 0.5 times 3 equal to 1.5, and then I use lambda equal to 1.5, and I'm going to find what is the probability that I found 2 gas stations between Americus and Albany, and that is equal to what? 1.5, go to the table, probably it's easier to go to the tables. 1.5, 2 is 0.2510. Okay, so this is don't do the other way. You have to adjust first your lambda for your number of kilometers or miles or time or whatever. Let's say I have 3 customers every 15 minutes. I want to know what is the probability of getting 15 customers in the next hour. I have to adjust my lambda times 4 because I have it in 15 minutes. And that's it, guys, really. This is all about Poisson distribution.